hold the mic. Yeah, your presentation will be recorded. Yes. And
the slide next here.
Yeah, exactly.
Okay. Hi, good morning, everyone. I'm Fanhua from Nanjing University, China. So I extended my talk a little bit, and my talk is leveraging green spaces to grow the city. It's a multi-scale and multi-dimensional study. So this talk will include 4 parts. The first, see the background. Okay. Now the cities get warmer with global warming and rapid urban growth, and changes in the composition and configuration of urban landscape directly affect the urban thermal environment. So the exacerbated urban thermal environment poses additional stress on human thermal comfort and health. And it was reported that more than 800 urban areas in Europe, it was uh, uh, about 20,000 deaths per year due to the heat. So there is an urgent need for the development of strategies in cities to mitigate the expected uh, increased temperature. So the green space has been studied extensively. So the green space can cool the city by increase the tree cover area and density. But mostly the tree can cool the city because the direct heating and the evapotranspiration. So on another way, the green space can bring lots of other ecosystem services, like can reducing stormwater, increasing the warmer, decreasing the biodiversity, and provide the beauty to the city. So my study objective is to how best to leverage green space to mitigate the urban thermal environment and help the city to adapt to the climate change. So my study area mostly in the Nanjing city. So Nanjing is one of the 4 furnace cities because it's hot and humid weather conditions in the summer. And it was reported that since 1951, it had the temperature exceeded 40 degrees centigrade. And also from 1970 to 2020, almost more than 600 days held heat waves. Um, so the cooling effect of the tree, different species of the trees, it was find that it's differed because of different species, and the canopy size, structure, and density also impact their cooling effect. And usually we use the LAI, the leaf area index, or sky view factor to measure how the tree impact their cooling effect. So, however, the LAI, this slide is a little different. I think I copied the wrong one. So the LAI, we usually cannot measure the 3D dimensional character of the tree canopy. And also the sky view factor, it's a constant value and cannot change with the time. But most studies have found that the cooling factor of the trees can change in a day. So we need to find the better metrics to value the tree canopy and how they work. So the objective of this scale, I want to measure the canopy structure with the above ground biomass and the shade, and then find out how the volume of above ground biomass and shade can impact the cooling effect. So here I use the Hubble station and the LiDAR to collect all of the data. And in this study, I studied the 3 species, and another one is the broad-leaved mixed forest, and a reference point to measure how the cooling effect. The study is in a botanical garden in Nanjing City, and then I used this LiDAR data to get the volume of the above ground green biomass, and then I use this light data and supported by the ArcGIS platform and to get the shade area to calculate the shade. And then finally, I will give a simple results. The cooling effect we find, the different species are totally different, and it was impacted by the by the canopy structure. And also we find that the volume and the compare the volume and the LAI, the volume can offers a better explanation on the tree canopy cooling effect. And this graph shows the LAI and no, that's the sky view factor and the shade. And it's also the shade we calculate use the light data and the ArcGIS and find the shade can offer a good explanation. This is the local scale study. I try to find how the species and the canopy can impact the cooling effect. And the next scale is in a block scale. And this part is I find out how the green space, the cooling effect and impact the energy saving. So most study we do the energy saving is we do in two-dimensional, and also some do the research that the tree near the house and then how the shade and impact the indoor energy saving. But the green space create a core island. It's like a dome. It's in a three-dimensional. So how we can calculate, how find out the this green space patch, especially not only a single but several patches out the door, how many the energy they can save. So in this study, this study is conducted in our Glue campus of Nanjing University, and I use the AVMAT model. I think lots of research know this model, and I analyzed I set two scenarios, one with and without green spaces. So here I use the observations and in the campus. And this the result. And this scenario with the green space, we can see the difference. And then without the green spaces, this air temperature is 1.5 meter height. And then I compared these two scenarios and only do the only analysis. We can see the green space where there the green space is can have the very clear, very significant cooling factor. And here no, this figure shows a vertical profile and with the green spaces and without the green spaces. So, and then I use, because in the campus, the average building height is about 30 meters. So I calculate how these green spaces in the campus can save the energies, use this formula. It's a very simple formula. And the result shows in the daytime, and in this special day in the summer, and all of the green space can work like more than 300 air conditioners are working in a day. So that's what I get in a block scale. And in the city scale, as I also use a 3D information. And so optimize urban landscape pattern is one way to mitigate the urban thermal environment. But however, usually the two-dimensional metrics fail to quantify the real urban landscape pattern. Then I try to use the 3D metrics to assess the urban form and then how the urban landscape impact the urban thermal environment. And so the objective is what kind of variable related to 3D urban landscape pattern which impact on the outer thermal environment, and how do we incorporate or blend this 3D information into the urban climate models to quantify the outdoor thermal environment, and then guide to plan and design the urban to improve it. So here, this is the study area, most of the Nanjing city, and this is the Purple Mountain. Maybe some friends have been to Nanjing University and the Xiang Lake, and we use the light data and also the hub stations. So this is the 3D landscape pattern matrix. So the building volume and also the sky view factor, especially as on the local scale, what I use is the about green space that's very teaching about ground biomass and this 3D matrix. And then I use the UMEP and the survey model to simulate the thermal environment or the study area. And I will not explain detail how this the process to get this data and all these metrics. We use the LiDAR software like LiDAR 360 or last draws, and then this supported by the ArcGIS platform, and then the result shows it's really different in the data thermal environment. I will not explain in detail where is the high, where is low the thermal environment, but it's really different in the daytime and at the night, and also the thermal environment. So in the day it's very different, especially, and by in the night it's much better. And so there's a relationship between this 3D urban landscape pattern and all the thermal environment. And I find that the 3D urban landscape metrics are significantly correlated with the thermal environment, and especially the above ground biomass and the normalized compact roughness, and also the sky view factor are impact metrics. So actually, I give this talk is not only show how this 3D, no matter the tree canopy or the 3D urban landscape, but I really want to see, yes, in the future. So the thing is, I use the UMEP or survey. I simulated and then find how the 3D impact this thermal environment. But the better way is we already included this 3D matrix in this model, and then we find how the thermal environment is. But now we cannot find a model can blend all of these metrics, 3D metrics in this model. Mostly are only sky view factor. So that's the problem. So, and the conclusion is, sorry. Oh, okay, there. Yeah. Yeah. So so my the study found that the shading green space can help to cool cities and bring energy saving, and the green space 2D or 3D patterns impact the cooling effects of the green space. However, how we can blend this 3D information to the urban climate models to better leverage green space to the across the city. That's an important thing I want to say. So thank you. Thanks for your attention. That's my talk.
Thank you very much. We have time for one question.